Hello everyone. In this video, Gravitation 2, I will be talking about acceleration due to gravity, gravitational potential energy, and escape velocity. Okay, so first we can see acceleration due to gravity. The acceleration produced in a body on account of Earth's gravity is known as acceleration due to gravity. We can observe that if we drop a ball from a building, the ball is accelerated as it goes down. This is due to the acceleration due to gravity. It always towards the center of the earth. It is always directed towards the center of the earth. This is usually denoted by the small letter g. Now force on a body of mass m on surface of earth is equal to, by the universal law of gravitation, F is equal to g into capital M into small m divided by r square, where capital M and capital R are the mass and radius of Earth, and small m is the mass of the body. Now, from Newton's second law of motion, we know that acceleration is given by force divided by mass. So, acceleration due to gravity g is equal to F by m is equal to gm by r square. So, this is the formula for finding the acceleration due to gravity. Here m is the mass of the earth and r is the radius of the earth. Now we can see the variation of acceleration due to gravity. The acceleration due to gravity in earth on earth varies with respect to the position of the object. We can see that. First is the effective altitude, that is, if a body is kept at a height h, then the acceleration due to gravity h, that height is given by g by 1 plus h by r the whole square. That is, the acceleration due to gravity decreases as the body's height increases. If the height h is very small compared to the radius of the earth, then using binomial theorem, we can get this equation, that is gh is equal to g into 1 minus 2h by r, where r is the radius of the earth, g is the acceleration due to gravity. The acceleration due to gravity, as found out by experiments, is almost equal to 9.8 meters per second square on the earth. Now, effect of depth. If a body of mass m is kept at a depth of d from the Earth's surface, then the acceleration due to gravity at that point is given by this equation. That is, gd is equal to g into 1 minus d by r. In this case also, the acceleration due to gravity decreases. The acceleration due to gravity at the center of the Earth is 0, as we can see from this equation. That is when d is equal to r. Now, effect due to rotation of Earth. Due to the variation of g with respect to rotation of Earth can be found out using this equation. That is, g theta is equal to g minus r omega square into cos square theta. Here theta is the latitude and omega is the angular velocity at which the Earth rotates. So if the rotation increases, the acceleration due to gravity decreases. And similarly, if we consider the case of latitude, if latitude increases, that is, If it is 0, then the value of cos 0 is 1. But the value of cos 90 is 0. Hence, with increasing latitude, the acceleration due to gravity increases. So, effect due to the shape of the Earth. The equatorial radius of Earth is more than that of its polar radius. The value of G increases from equator to pole. Now, gravitational potential energy. The work done in displacing a mass m from infinity to that point is called gravitational potential energy. Gravitational potential energy of two masses m1 and m2 separated by a distance r is given by V. V is used to denote gravitational potential energy is equal to negative gm1m2 by r. The gravitational potential due to the gravitational force of the Earth is defined as the potential energy of a particle of unit mass at that point. Now we can see the concept of escape velocity. Escape velocity is the minimum velocity required to project a body vertically upward from the surface of the Earth so that it comes out of the gravitational field of Earth. It is the velocity with which the body has to be projected. For example, if we throw a stone, it always comes back. But in the case of satellites, we have to project it outside the Earth's atmosphere. For that, we use high-speed rockets. And these rockets go at a velocity which is greater than the escape velocity. And the formula for escape velocity is given by root of 2 into gm by r, or is equal to root of 2 small g r. Here r is the radius of the Earth and capital M is the mass of Earth and g is the universal gravitational constant. So this is the end of this video. In this video, I have discussed the concepts of acceleration due to gravity, its variation depending on various factors, the gravitational potential energy, and finally the escape velocity. Thank you.